Hey everyone, welcome back to our channel. So today's we are diving into the advanced API design to handle the file encryption and decryption using the Golang. We will making the one app that is accepting the file using the encryption, and it will also giving the decrypt the file using the reverse encryption. And we will also follow the features like secure the key management, logging for monitoring when we are uploading the file, and we will also giving the option like downloading the file. So without wasting your time, let's get started. So first, I'm going to the VS Code, and here here we will create some basic files like main.go, handlerscode.go, encryption.go, key management logic, and utility functions, and asset folder for store the files. So without wasting your time, let's get started. So first, open the terminal, go mode init, encrypt, decrypt, file, Golang. So I have created one go.mode file which is for running our project. Then afterwards, main.go I have created. Here, now we will start writing the code. Package main function main http dot handle function handlers dot. So we will create one more file which is called the handlers.go, handlers.go, and simply we can write package handlers function encrypt handler key response writer http dot request import Same for the decrypt handler. Now go to the main.go file and write encrypt handler. Encrypt. Encrypt file handler. Decrypt file handler. Then afterwards, we will see whether it is perfectly working our code first. Um, 800. TP dot listen sum. Now check whether it is running or not. Go run main dot code. Okay. Package encrypt and decrypt to a file Golang handler is not. So this is the error that we are facing. We will see how we can resolve. So we need to create one folder, handler, and then afterwards we will move into this file. Now I think error is gone, but still I think we are facing some error. Package encrypt. Okay. Okay, this is wrong. We need to, if we put inside this package, okay. We will separate this file, encrypt and decrypt, um, so that we will easily decrypt code, and pin code we will write here with package handlers. To encrypt and decrypt, think here it is something we will lack here. Package handler. Okay, this is the spanning listing that we have done so far. So encrypt file handlers. Now I think it is done. Okay, now it is done. Our server is running successfully in 8080 port. Now what we can do here it is, first we can write the code for the encrypt file handler. For that, we will make one another separate folder called encryption, and inside the encryption, first we will write the uh, encrypt file and decrypt file. Or simply we will name it as a, we will make the separate logic for that encryption and decryption, so that it is a clearly concise the code. Okay, so first encryption, here we will rename it is encrypt handler. Encrypt dot pro package encryption and decryption dot co package decryption. Okay, now we will start writing the code for the encryption. So first, um, we will write the function encrypt file path string key of byte, and we will simply return byte. And so first we will creating the AES block, which is called the advanced encryption standard, which is use the symmetric encryption algorithm. Then we will also implement the zipper tags length. So zipper tags is a equal to the AES block size, and basically it will randomly generated and prepended to the zipper tags for the secure encryption. So this is called the initialization vector. And we will also implement the cipher feedback mode, where each zipper text box block affects the encryption of subsequent blocks. And we will also implement error handling, check for the errors during the file reading and zipper block creation, and initialization vector generation and decryption. So first we will write the code here. Read the plain text from the file. Plain text error os dot read file path. Then afterwards, if error, here we need to import the OS package. Then afterwards, first step it is called step 1 is create a new mesh zipper block using the key block error AES zipper new zipper key. Then afterwards is error could not create zipper block. Error Then afterwards, step 2, create create a slice to store the zipper tags. So zipper tags make byte AES block size plus length plain text. Here we made the spelling mistake. Please correct it. Then afterwards, generate a random initialization vector. Initialization vector. Step 3. So IV zipper tags is block size if so it will a initialization vector to the point to the first ES block size byte of zipper tags. Okay. Then it will generate the random initialization vector by reading the random byte into the initialization vector using the rand.read method. So here we will provide the initialization vector and check there is no error or not, and simply we will generate. If it is something is broken during the initialization vector, then it will return the error. Then step 4, initialize the advanced encryption standard uh, using cipher feedback mode to encryptor with a block and initialization vector. So step 4 it is initialize the AES cipher feedback mode, advanced encryption standard and cipher feedback mode encrypted with block and initialization vector. So this is how we have on one more step it is remaining, which is called the extract the plain text and store it into the cipher text slice. So string dot I think it is right. Okay. So it will encrypt the plain text using the XOR key stream and store the encrypted data started at cipher text block size. And then afterwards, it simply return the plain text, return the encrypted plain text, return plain text. So this is how we have completed encrypt file, and now we will go ahead with the decryption. So in the decryption, function decrypt file paper text byte byte array. So first we will create a new advanced encryption super block, advanced encryption standard super block using the provided key. Okay, so step 1, I think it is perfectly giving the suggestion regarding the code, but the thing is we will not use it this code, we will only use the comment block array es dot new super, and then afterwards we will provide the key here. Then afterwards, if everything is running smoothly, we will check here whether it is a error or not. So that is the reason we will implement if else if block print we can't use this import, and simply we will use fmt fmt when I'm saving the file at that time, it will change here. So I can't save it right now. Okay, because of the extension that I have installed in my local system, that is the reason. Basically not allowing, it will formatting automatically code here. But I think it is right. Giving the suggestion is right. Crypto AES. So crypto AES package. So crypto AES package provides the advanced encryption standard blocks zipper algorithm implementation, and it will allow the encryption algorithm that use the fixed block size like 16 bytes and support the key size of 128, 192, and 256 bits, I think. And yeah, so that's it, I think. So yeah, once again we will return the code and show the zipper tag length is at least AES block size. So if length of triple tags less than the block size, then we will simply return empty dot error of triple tags is too short. Then first step is completed. Now second step is step 2 is extract the initialization vector from the zipper tags, and here zipper tags AES block size we will define, then afterwards extract the actual encrypted data, here excluding the initialization vector, and zipper tags zipper tags yes. Then afterwards step 3 we will actually make here step 3. Step 4, initialize the advanced encryption standard ciphertext feedback decryptor with a block and initialization vector. So initialize the decryptor with the block so it will basically what here you can do Okay, we need to import one more package which is called the crypto shipper. Crypto crypto shipper. Then afterwards, step 5 is create a buffer to hold the decrypted plain text. Create a buffer to hold the decrypted plain text. Plain text. Make byte equal text decrypt the simple text and store the plain text in the buffer. Stream. So this is called step 6. Return the decrypted plain text. Return plain text. So this is how we have completed the decryption. Now we will implement in the encrypt and decrypt handler. We will take 2 minutes break here. So now back to the code. First, we will go to the encrypt file handler and start writing the code. If r dot method does not equals to http dot method post method, then http dot error invalid request method, and http dot status method not allowed, and simply return. Then afterwards key error key manager unit unit key. So we need to implement basically key manager in our project. So simply we will create key manager dot code and start writing the code for that. First is package key manager, we need to create the folder for that. I think key manager, and go to inside the folder, and basically now the line initialize. So first I think here we will generate the key, that is make function we will use here, and byte 32. So basically I think asymmetric encryption standard requires the 32 bytes, so that is the reason we will use here 32 bytes. So this is the requires 32 byte key. Okay, then afterwards we will use the error block and read p if error return fmt dot error could not generate key. Also import so basically these lines initialize the byte slice key with the length of 32 bytes, and it will actually require for AES 256 encryption, that is up to the 32 bytes. Then afterwards, uh, this package crypto forward slash rand, so it will actually basically it will not basically this function. So basically cryptorand packet to fill the key slice with the cryptographically secure the random bytes, and it will ignore the number of the bytes to read, and error captures if any error during the generation of a random byte. So this is how we have completed this function, and here we will simply return the key after the successfully created the key. So now back to the encrypt handler. Now here we will use package, not encryption but key manager. Key manager in key manager then if then simply implement the things like fmt.print f import the package fmt error generating key http dot status internal server error, and simply return. Then afterwards, we will reading and handling the file uploads. So how we can achieve this? First step is here, generate a new key using the key manager package. This step also, we will export our key using the environment variable file. We will directly using the environment variable for the key generation, and simply we will use it. But in upcoming videos, I will cover that kind of a concepts. But right now we will use the key manager for generate the key. Then afterwards, we will simply encrypt the file using the key. So step 2 is encrypt the file using the key. File, then afterwards error block is there, and r dot from file. If http dot error print error reading file, http status internal server error. Not a error, but a status bad request, and you return it. So here, and, simply defer dot file dot close. Ensure that file is closed after the processing. If it is everything is correctly going, then afterwards so today we will stop here live session, and in upcoming videos we will continue with encrypt file handler. So see you later, and if you like this content, don't forget to subscribe and uh, enable the bell icon. So see you in the upcoming videos.